Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and welcome all to the viewers and listeners. I am Khairul bin Cekmat alongside with research colleagues Nur Hafzan binti Bariman. We are from Polytechnic Muazzam Shah. Will be presented our research title, that is Effect of Cutting Parameter on CFRP Hole Quality using Helical Milling Techniques in this Matrix 2021. Our content of presentation includes introduction, methodology, result and discussions, and last, concluding remarks. Go for the introduction. Okay, first of all, what is CFRP? CFRP stands for Carbon Fiber Reinforced Plastic. It's a composite material consisting of various carbon fibers and thermosetting resin. In the animation, so the carbon fiber and the resin matrix are combined to make the CFRP, which will produce high performance material with new properties. Usually CFRP are been stacking up by two ways, that is, one is unidirectional layup or lamina, and second is quasi-isotropic layup, or we call it laminates. In this experiment, we'll be using the laminate CFRP. In terms of the application of CFRP, nowadays a lot of the CFRP are being using in the aircraft industry, which you can see in the Dreamliner 787. It consists of 50% of its body structure using the composite material. You can see also in the Airbus industry from 1970 to 2010, the use of the CFRP are increased gradually. Other industry that use CFRP, you can see in the bicycle industry, in helmet, building construction, and also automobile part. And we go for its helical milling. Helical milling is milling tool rotates on a helical path and generate the borehole. This is the animation. How is the helical milling? So you can see that it has the helical diameter and the bore diameter. The advantages of the helical milling is less delamination in CFRP, low process force, and good cheap transportation. This is important because in making a hole on the CFRP, delamination must be controlled. Objective and overview on this experiment. The objectives are to evaluate the effect of cutting parameters on the cutting force and the hole quality, and the experiment overview that will be conducted using a vertical milling machine, solid MC430L, cemented carbide WCCO, and mill with 4 flutes, 3 level of cutting speed and 2 level of feed rate, and evaluation on 2 level of depth per helical path for each cutting conditions. We go for the second content, that is methodology. So for the methodology, first we'll be looking at the end mill cutting tool use. The end mill cutting tool use are type 4 flutes, 6 mm in diameter. The material been said earlier that it is solid carbide. The ISO code for the solid carbide is K30. This is the view of the end mill cutting tools. You can see on the top view, the side view, and the end mill cutting edge. 3 level of cutting speed are used, and 2 level of feed rate, and also 2 level of depth per helical path. The coolant are dry. So for the experimental setup, you can see the machine use solid 430L, and below the picture are how is the workpiece being set up in the machine. Okay, we'll be using the dynamometer Chrysler 9250. On top of that, we have the jig, and on top of the jig, we have the CFRP material we'll be stacking up. So the dynamometer will be connected to the amplifiers to get the readings, and the reading will be collected to the PC. So when the experiment started, okay, the reading will appear onto the PC. We go to the third contents, that is result and discussion. First of all, we'll be looking at the thrust force. We'll be evaluate on the three factor, that is effect of feed rate, effect of depth of cut, and effect of cutting speed. From the graph also we can see that high feed rate will produce high thrust force. This is because larger instantaneous cutting area does require more power. For the effect of depth of cut, it's also the same. High depth of cut will produce high thrust force. This is because more material being removed per unit time that increase the energy requirement linearly. And last, effect of cutting speed. You can see that high cutting speed produce lower thrust force. This is because the faster of the tool rotate make small contact area between the tool and chip interface, thus reduce the coefficient of friction. Next, we go to the delamination factor. Also, we'll be looking at the three factors: effect of feed rate, depth of cut, and cutting speed. You can see the pattern also same, that high feed rate will produce high delamination. This is because effect and influence of the thrust force. For the effect of depth of cut, also you can see that high depth of cut produce high delamination. For the effect of cutting speed, you can see that there is no insignificant effects. So we move on to the hole quality, the exit area. First of all, for the 0.3 mm depth per helical path, in the delamination, you can see that the delamination occur a lot in the 0.06 at feed rate mm per tooth. And also we can see that there is also uncut fiber occur. Second, we go for the depth per helical path at 0.6 mm. Also the same, that you can see in the delamination, you see it occur most at 0.06 mm per tooth feed rate compared to the 0.03 mm per tooth. Also, uncut fiber happen a lot at 0.03. Okay, lastly we go for the concluding remarks. Okay, for concluding, we can say that helical milling experiment that I carried out to investigate the effect of the cutting parameter on the hole produced onto the CFrP material. The results are as follows. First of all, we can say that higher feed rate produce higher thrust force and delamination. Second, feed rate have larger influence to the thrust force compared to the cutting speed. And lastly, the feed rate at 0.03 mm per tooth gave better performance than feed rate at 0.06 mm per tooth in terms of thrust force and delamination factor. And that wraps up our presentation here. So thank you all for listening, and have a pleasant day. Assalamualaikum warahmatullahi wabarakatuh.